I hope you remember what we covered in the last class. We were on problem sheet number 8, and I think we have 2 or 3 problems left. We'll quickly cover those before we move on to the next topic. So we are on problem number 8 now, right? We're done with 7. All right. So we'll move to question number 8. Question number 8. In the equation 4 times x minus 2 plus x is equal to lambda x minus 8, lambda is a constant. Which of the following values of lambda will not result in an equation with a unique solution? So you understand the question? In the equation 4 times x minus 2 plus x is equal to lambda x minus 8, lambda is a constant. So we know that is a linear equation in just one variable x, and lambda is given to be a constant, and we have to choose that value of lambda in such a way that it will not produce, the given equation will not produce a unique solution, right? So our first step is convert this equation into standard form. If there are brackets, you have to expand them. If there are like terms, you have to combine them. So on the LHS, so our question is 4 times x minus 2 plus x is equal to lambda x minus 8. Now see, we can expand the bracket. So we have 4x minus 8 plus x is equal to lambda x minus 8. Now on the LHS, you can combine the like terms. There is 4x and x, so that is 5x. 5x minus 8 is equal to lambda x minus 8. Now you observe that the constants are exactly the same, right? The constants are exactly the same. The constants are exactly the same. Now, remember, if the coefficient of x also happen to be the same, you will have identical expressions on both LHS and RHS. See, if lambda happens to be 5, what happens? If lambda happens to be 5, you will have identical expression on both sides, right? If lambda is equal to 5, just think about it. What happens? Lambda happens to be 5. What happens? The expression on both LHS and RHS will be identical, which means they will have, the equation will have, what is the case here? Please tell me. The equation will have, please tell me what is the case here? Yeah, this will have infinite solutions, right? Because the expressions will be identical. I hope this is fine. I hope this is fine. Yeah, cool. So whenever lambda is not equal to 5, whenever lambda is not equal to 5, what happens? Whenever lambda is not equal to 5, lambda not equal to 5, this minus 8 and minus 8 can be cancelled off. Okay, now as long as lambda is not equal to 5, 5x is equal to lambda x will result in a unique solution being x is equal to 0. x is equal to 0 will be a unique solution, right? So as long as whenever lambda is not equal to 5, you can just write x is equal to 0 as the unique solution, right? But when lambda is equal to 5, that is not possible, because when lambda is equal to 5, the expressions are exactly the same on both sides. So 5x is equal to 5x will be satisfied by any value of x. So this means this will have infinite solutions. Right? On the other hand, if lambda is not equal to 5, what does it mean? 5x is equal to lambda x. What does this mean? This simply means x is equal to 0. All right. You can understand in this way as well. Bring everything to one side. Bring everything to one side. So we have lambda x minus 5x is equal to 0. So this is lambda minus 5 times x is equal to 0. Now, the product of two numbers is 0. What does that mean? Product of two numbers, lambda minus 5 and x is equal to product of lambda minus 5 and x is 0. Which means at least one of them is 0, right? Product of two numbers is 0, which means at least one of them is 0. Okay. Now, suppose if lambda is not equal to 5, lambda is not equal to 5 means what? Lambda minus 5 is not equal to 0. So this cannot be 0, which means this has to be 0. You can interpret in this way as well. You can understand in this manner as well. Okay. Even otherwise, it's just an observation. When lambda is not equal to 5, say lambda is equal to 6. Say for example, 5x is equal to 6x. What is the solution? X is equal to 0, right? There are no other solutions. There are no other solutions. There is just one solution. So this is a case with unique solution. All right. Got it? Shall we move on to the next problem? Now, what is the answer? What is the answer to the question? Which of the following values of lambda will not result in an equation with unique solution? The answer is 5, because any number except 5 will give you an equation with unique solution. And when lambda is equal to 5, that will lead to an equation with infinite solution. All right. Shall I move on to the next question? Next question. This is all right. Yes. Yeah. Okay. Now, in question number 9, in the equation 2x minus 1 is equal to minus 1 plus ax, a is a constant. Which of the following values of a results in an equation with infinitely many solutions? Again, you just look at the expression. It's already simplified. There is no further simplification required because there are no brackets to expand. There are no like terms to be combined. So we need to look at the case where there are infinitely many solutions. So when they say infinite solution, it should strike you immediately. They are talking about identical expressions on both LHS and RHS, right? Right. So we are looking at identical expressions on both sides. So we need to have 2x minus 1 is equal to ax minus 1. These expressions should be identical on both sides. So it is very obvious that it's immediate observation that a has to be equal to 2, so that the equation will have infinitely many solutions. All right. Yes. Cool. Tell me. Yes. Okay. Please let me know. Please let me know if it's okay. Yes. In question number 10, Question number 10. Which of the following best describes the solution set to the equation shown above? So we have an equation. Of course, our first job is to simplify the expression. So when you look at the RHS, there are like terms to be combined. In fact, it's 6x and 6x. Those will get cancelled. So we have 4 minus 3x is equal to 4. 4 minus 3x is equal to 4. Again, on both LHS and RHS, you can cancel 4 on both sides. So we are left with minus 3x is equal to 0. You understand me, right? Right? You cancel off 6x and minus 6x on RHS. That goes away. Now you have 4 minus 3x is equal to 4. You just cancel off 4 on both sides. Now you are left with minus 3x is equal to 0. Now immediately x is equal to 0 is the solution. So the answer is the equation has exactly one solution, which is x is equal to 0. The equation has exactly one solution, which is x is equal to 0. Cool. Yes. So this topic took us some time, but it's important to note that such questions will definitely come in an SAT, and this is supposed to be the most difficult topic from the linear equation in one variable topic area, right? So we have seen so many examples. We have seen a variety of examples. Ultimately, I told you, if you see a lot of questions, if you practice a lot of questions, if you go through enough drilling, during an actual exam, time is a big factor. So if you have sufficient practice, you should be able to come up with the answer in a few seconds as demanded by the exam. All right. So shall we move on to the next topic? Tell me. Yes. So the next topic is equations. So we are on linear equations in one variable. And linear equation in one variable, what does it mean? The power of the degree of x will be 1. So we will have an equation in which degree of the variable will be 1. But there are equations which may not look like a linear equation, but if you just manipulate it slightly, they can be converted to a linear equation. So we are going to see such equations. You understand my point? There can be equations which do not look like linear equations at all. But if you do some slight manipulation, you can convert them into linear equations. All right. So we'll be seeing such equations. Say, for example, 1 by n, 1 by x plus 1 by 3 is equal to 1 by 2. At first glance, is this a linear equation? Is this a linear equation? Does this have linear expressions? No, obviously no. Because you have expressions in the denominator. Okay, a linear expression will always look like 2x plus 3, 5x plus 7, ax plus b, mx plus c, right? This is how a linear expression will look like, and a linear equation will look like one simplified, right? So in this case, at first glance, this may not look like a linear equation, but if you do some manipulations, you can convert them into linear equations. Okay. So let's see how we can solve these kind of equations. Before that, often what happens is there can be terms which appear on denominator. Okay, so once you have an expression in the denominator, you should be very careful. Why? Because why why because why you should be careful about expressions that occur in the denominator of a fraction. Why you should be careful? Why you should be careful? See, when you have a denominator, you should always make sure that the denominator is not zero. The denominator is not zero. Okay. I'll give you a quick example to understand what I'm talking about. Let's see a question. See, listen carefully. So let's have an equation of the form x minus 1 divided by x minus 1 is equal to 1 minus 1 divided by x minus 1. Now, this is not a linear equation. This is not a linear equation. Let's see how you can solve this. Can you just try it? Take a minute or two and just try this question. See whether you can solve this question. Others, 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 please do let me know. Just, yeah, what about others? Just let me know what you think of this equation. Just let me know what you think of this equation. Just let me know what you think of this equation. That's all. Please, I need a response from everyone. Just let me know what you think of this. That's all. Even if you cannot solve, just share your thoughts. Just share your thoughts. Yeah, what about others? What about others? I've got two answers so far. Please do respond. Just you could message me privately as well. Message me privately as well. I'm just checking your chat on the second device. The device which says host. What about others? Others. Yeah. Okay. Now listen very carefully. Okay, listen very carefully. Of course, the first thought that comes to your mind is you can just get rid of this term. Right? 1 by x minus 1, 1 by x minus 1 goes away. Right? That looks pretty straightforward. Now we are left with x is equal to 1. Okay. Now you might want to think that x is equal to 1 is a solution to this equation, but there's a catch. There is a catch. Can somebody tell me why? Of course, you can cancel off 1 by x minus 1 on both sides, and you are left with x is equal to 1. And you might want to think that x is equal to 1 as a solution to this equation, but there's a very big problem. Can somebody tell me what it is? I'm sure you would have come across this equation before. Yeah, some person has given me the answer. What about others? What about others? What do you think is the issue with x is equal to 1? Why can't I say that x is equal to 1 is the solution to this equation? Okay, listen. Now you got x is equal to 1, right? Now what is the meaning of solution to an equation? It should satisfy the equation, right? It should satisfy the equation. Now let's see whether x is equal to 1 will satisfy our original equation. Our original equation is x minus 1 by x minus 1 is equal to 1 minus 1 by x minus 1. Now when I go and substitute x is equal to 1 in the original equation, what happens to this expression? What happens to this expression? It becomes undefined, right? When you have x is equal to 1, the x minus 1 term in the denominator becomes undefined, right? Because you have 0 in the denominator. Can you have 0 in the denominator? Can you have 0 in the denominator? No. That is a problem. That's a very big problem. You can't have 0 in the denominator because that becomes undefined. That's not a real number. So even though you might think that you have got the answer as x is equal to 1, you have to understand that this original equation is defined only when x is not equal to 1. Okay, so this equation will be true only if x is not equal to 1. When x is equal to 1, this equation does not make sense. Okay, this is invalid. When x is equal to 1, this equation, the original equation, becomes invalid because there are undefined terms in the question. You understand my point? So when you have 0 in the denominator, when you have 0 in the denominator of a term, that term becomes undefined. If you have such terms in the question does not make sense, right? Got it? Yes. Yes. So we are moving on to the next type of equations, which might have terms in the denominator. So before solving those kind of equations, you should be able to tell. You should be able to tell when such equations will be undefined. Okay. So we'll do some 2 or 3 problems where we have to figure out when the expression becomes undefined. After that, we'll move on to the questions I was talking about, the equations which can be converted to linear equations. So before actually solving some equations, I'm going to show you some examples. I'm going to show you some examples in which you have to tell me when this expression becomes undefined. Okay. Let's see some examples. I'll just share the next problem sheet with you. I'll share this immediately after the class as well. Yes. So we're just discussing this idea. A fraction becomes undefined when its denominator becomes 0. It is important to figure out when a certain expression becomes undefined when encountered with algebraic expressions in the denominator. Let's see first question. Just let's just quickly see one or two questions before we move on to the problems. I was talking about the linear equations which can be converted, not the equations which can be converted to the linear equations. So first question, the value of x at which 1 by 2x plus 4 becomes undefined is. You can quickly tell me what the answer is. Can you quickly tell me what the answer is? Everyone, please let me know the answer. The value of x at which 1 by 2x plus 4 becomes undefined. So when you see such an expression, you should be able to tell when that expression becomes undefined. Be careful about the fact. Yes. There's just one thing to check. You cannot have 0 in the denominator, right? So your 2x plus 4, just let's check when the 2x plus 4 becomes 0. 2x plus 4 is equal to 0. So you have 2x is equal to minus 4. So you have x is equal to minus 2. So x is equal to minus 2 is the trouble point. Others, please do let me know. Got it? So x is equal to minus 2 is the answer. Robin, it's fine, right? Yes. Next question. For what value of x the fraction becomes undefined? Tell me quickly. Yes. The denominator becomes 0. Yeah. The answer is 8. Yes, very good. Next question. For what value of d in the fraction 3d divided by 6d becomes undefined? Okay. 3d divided by 6d becomes undefined. Yes. Say, you might want to think that you can easily cancel off these d and then you have nothing to worry about. But that's not how it works, okay? If you have some terms in the denominator, if you want to cancel off some terms, you have to first make sure that that is not 0. Okay. So if d is 0, you cannot do this cancellation. Okay. So this 3d divided by 6d can be written as 3 divided by 6 only if d is non-zero. This 3d divided by 6d will be undefined if d is equal to 0. You understand this point? You know what I'm talking about? Yes? Got it? So the point is you should be careful about the terms of the denominator. That's all. Okay? You should be careful about the terms of the denominator. That's all. It's no big deal. But you should be just careful. That's all. So the answer would be 0. For what value of d the fraction becomes undefined? The answer will be d is equal to 0. We'll make this expression undefined. Got it? Straightforward, right? Have you learnt about functions? I hope you would have heard about functions and its domain, functions, domain, domain of a function. Heard about functions? Functions. See, I'm sure you would have heard about, say, you have 1 by 2x plus 4. Sometimes you might want to call this as a function of x. You might want to call this as a function of x. Okay. What is a function? Basically, this is an input-output relationship. You just feed x to the function and it is going to give 1 by 2x plus 4 as the output. That's all. Say you feed x is equal to 2, you put x is equal to 2, the output it is going to give us 1 by 2 into 2 plus 4. This is what we call a function. There is an input-output relationship. Okay, and that is represented as an expression. Okay. And I'm sure you would have come across the term called domain of a function. Domain of a function. Do you remember this term, domain? I'm sure this comes in your Algebra 1 lesson. I guess this comes in your Algebra 1 lessons. Anyway, domain of a function is something. I mean, I'm just giving you some extra points. Okay, this is not relevant to our current discussion. We'll see this topic later on in detail. Okay, I'm just giving some extra points. Okay, when you represent this as a function, the set of all values of x, the values of x is what we call the domain. Okay, the set of all values of x is what we call the domain of a function. So in this case, you understand that x cannot be minus 2. X cannot be minus 2. So we say that x is equal to minus 2 is not there in the domain of the function. In this case, we say that x is equal to minus 2 is not included in the domain. X is equal to minus 2 is not included in the domain. Okay. What did I just say? If this expression, if I represent this as a function, in function, what do? We represent it as an input-output relationship. If you represent an expression as a function, here we said that this expression becomes invalid when x is equal to minus 2. If you represent this as a function, we will say that this number x is equal to minus 2 is not included in the domain, which translates to, what is the meaning of this statement? It means that your function cannot get x is equal to minus 2 as its input. X is equal to minus 2 cannot be given as the input to the function. That's all. Because, that will make the expression undefined. All right. So there are few more questions of similar kinds. Okay. I'll share the sheet with you. Just try to figure out this rest of the questions for the next class. It'll take a few minutes. Okay. Maybe 30 seconds for each question. Okay. I'll share the sheet with you. Please do work them out. Now we'll move on to the topic which I was talking about for long, which is equations that can be converted to linear equations. Equations that can be converted to linear equations. Okay. These are also common questions in SAT. So when you see such a question, you should be able to figure out what kind of an equation that is. And You should be able to crack it. Yeah. So idea we are discussing is simple. Some of the equations which do not look like a linear equation can often be converted to a linear equations. So that is the idea we are talking about. Okay. Let's see some questions. So first question. Solve for x. 6 and 1 by 4 divided by 2 and half is equal to 1 and half divided by x. Now, what is the first impression? Question number 1. What is the first impression here? We have 6 and 1 by 4 in the numerator. The denominator, it's 2 and a half. On the RHS, it is 1 and half. Yes. At first glance, is this a linear equation? At first glance, is this a linear equation? No, no, no. Right? This is not a linear equation. But if you think about it, when you cross multiply, this simply becomes a linear equation. When you cross multiply, just cross multiply, this becomes a linear equation. It becomes a very simple linear equation, right? Currently, you have x in the denominator. In a linear equation, you cannot have x in the denominator. But when you cross multiply, it simply becomes a linear equation. But remember, we just saw that whenever there are expressions in the denominator, before doing any operation, before doing a cross multiplication, before cancelling some term, you have to make sure that the denominator is non-zero. So in the beginning itself, just write that x is equal to 0. Okay. Now, why should you write that? Why should you write that? Suppose after solving this equation, your answer comes out to be x is equal to 0. You have to discard it. Because, why? Because x is equal to 0 will make the original equation invalid, right? X is equal to 0 will make the original equation invalid. So that is the point. Okay. When you come across a linear equation which can be converted to linear equation, whenever there are terms in the denominator, you have to first make sure that those terms are non-zero. So you just write that x is non-zero. Now, after solving this equation, if your answer comes out to be, say, x is equal to 0, you cannot accept it as a solution because, that will make the original question invalid. That is why I gave the first example. See, we have x minus 1 by x minus 1 is equal to 1 minus 1 by x minus 1. Okay. Now, you might want to cancel this off. But before cancelling, you just write that x cannot be 1. You have to keep this in your mind. Now you can cancel off this term. Now we are left with x is equal to 1. But since x cannot be 1, you have to discard the solution. And you will say that the equation has no solution. You understand the point? So whenever you get an equation, if you see terms in the denominator which will make the denominator 0, you just note it down. Okay? Before doing any manipulation, before doing a cross multiplication, before doing a simplification, before doing a cancellation, you just write down those values which will make the original equation invalid. Now, after solving an equation, if you come across those numbers, you have to discard them. You cannot accept those as the solutions because those numbers are going to make your original equation invalid. You understand my point? You know what I'm talking about? Got it? Simple idea. When you have terms in the denominator, you just have to be extra careful. That's all. You have to make sure that nothing is making a denominator 0. Right? Tell me, does this make sense? Does this make sense to you? Others, please do let me know. So in this question, we say the equation has no solution because we just got x is equal to 1 as the only solution. But unfortunately, you cannot put x is equal to 1 as a solution because it is going to make the original equation invalid. This is going to make the original equation invalid. So you have to be extra careful. That's all. So when you have an equation, when you have an expression in the denominator, you should be extra careful. That's all. Okay. Such tricky questions can come in an SAT. Okay, they do appear in an SAT exam like a SAT. Okay, so now let's move on to this question. So we were trying to solve this question. Let's see how this can be solved. So we have question number 1. We have 6 and 1 by 4 divided by 2 and 1 by 2, 1 and half divided by x. Okay. So the only thing you need to write is just write x is not equal to 0 along with the question. That's all. And after solving, suppose if you get x is equal to 0 as a solution, suppose you have to discard it. That's all. That's the only idea. Okay. Right? So when you see an equation, immediately make sure that the equation is not invalid. And after solving equation, if at all such a value appears as a solution, you have to discard it. That's all. Okay. Now, how can we solve it? You can just cross multiply, right? You can just cross multiply. Before cross multiplying, you might want to simplify those fractions. You have mixed fraction. You might want to convert that. So 6 and 1 by 4 is, how do you do that? It is 6 into 4 plus 1 by 4, right? So that is 25 by 4, right? So that is 25 divided by 4, 25 by 4. And what is 2 and a half? 2 and a half is 2 into 2 plus 1 divided by 2. So that is 5 by 2. And on the RHS, we have 5 by 2 is equal to x divided by x. Is this fine? Tell me if this is fine. Oh, sorry. I made a mistake. Because it's 5 by 2 here. It's not 5 by 2 here. It's 1 and a half, right? 1 and a half is 1 into 2 plus 1 by 2, which is 3 divided by 2. I'm sorry, I made a mistake. Please rectify it. Yes, got it. So now you just cross multiply. You just cross multiply. So tell me what is the answer. Can you tell me what is the answer finally? You just cross multiply and tell me what is the answer finally. Please cross multiply and tell me what is the answer. And by the way, you guys know how to deal with this kind of arithmetics, right? Converting mixed fraction into normal fraction. See, 6 and a quarter simply means it's 6 plus 1 by 4, right? So this is 6 into 4 plus 1 divided by 4, which is 25 by 4. That's all. 6 and a quarter means what? It's 6 plus a quarter. Can you please cross multiply, simplify the expression and tell me what is the solution ultimately? What is the final value of x? What is the value of x? Hmm. No, how can you say infinite solutions? Yes. Yeah, yeah. Please take your time. No issues. No issues. Take your time. This might take some time for the time being, but with a lot of practice, in the end of this program, you should be able to do this question very quickly. And know, let me fix it. 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 I'm sorry. Is it fine now? Is it? Yeah. Okay. Yes. I'm very sorry. I mean, I don't know what went wrong. I got disconnected. I'm sorry. Yes. How do you cross multiply? How do you cross multiply? So when you have something of the form a by b equal to c by d, this simply means a into d is equal to b into c. A by b equal to c by d, it simply means that a into d is b into c. A times d. I mean, here in India we say into. A times d is b times c. Right? So we have 25 by 4 divided by 5 by 2 is equal to 3 by 2 divided by x. So when you cross multiply, what do we have here? We have 25 by 4 into x is equal to 3 by 2 times 5 by 2. So you're happy now. Why? Because why? Why? Because this 2 into 2 is 4, which can be cancelled with 4 here. Right? This 5 can be cancelled with 25 here. So you have 5 here. So we have 5 times x is equal to 3 times 1, which is 3. So your x is 3 by 5. Does this make sense? Does this make sense? Tell me if you're struggling at some step, do let me know. If you're struggling at some step, do let me know. Uh, Robin, Prisha, Olivia has already given me the right answer. Is there a problem, Prisha? Robin, yeah, it's fine. Prisha, are you with me? Yes, cool. Now let's see another question. Another question. And by the way, lucky for you, good for you. You got x is equal to 3 by 5 as the answer. Okay. And this does not create any problem here. Okay. This does not create any problem here. Okay. If we had got the answer as x is equal to 0 here, you should have discarded it. That's all. Because you can't accept x is equal to 0 as the solution. That will make the original question invalid. So here there's no problem. You just accept, you can accept x is equal to 3 by 5 as the solution. And the answer is right. Okay. Yes. Second question. The solution of 7 over 16x minus 3 divided by 10x is equal to 1. Can you quickly try this? Take a minute or two. Quickly try this question. Can you? Again, when you look at the question, this is not a linear equation because you have x terms in the denominator. It's not acceptable in a linear equation. But this is an equation. This is not a linear equation. But the idea is when you simplify it, you can convert this into a linear equation. After some manipulation, this can be converted to a linear equation. That's the idea here. Yes, very good. 11/80 is the answer. That's very good. So first step is you have to make sure that the denominator does not become 0. So whenever x is equal to 0, this question becomes invalid. So you have to explicitly write down that x cannot be 0. In the end, if you happen to get x is equal to 0 as a solution, you have to discard it. That's all. It's highly unlikely that you will get x is equal to 0 as a solution, but you have to follow this procedure so that you don't make a mistake. Sometimes questions can get tricky. Okay, what about others? Others, are you still struggling with this question? Yeah, one more person has the answer. It's very good. That's very good. That's cool. Cool. I'll quickly do it. I'll take two more minutes before we wind up. Please listen carefully. See, and by the way, does everyone have an iPad or a writing device? If you want any help with the simple arithmetic, maybe I can see you working. Maybe help you with the steps or something like that. Or everybody is watching on a computer. Is everyone watching on a computer, or do you guys on an iPad or something like that? Okay. Anyway, if somebody wants help with the arithmetic part, okay, just get back to me. Okay, just get back to me on WhatsApp or something if you need additional help, because this question might look difficult, but it's not actually difficult. See, what you have to do is you just take x outside, okay, but x is in the denominator, so it's actually 1 by x. Do you understand this step? If you understand this step, then you're done. If you understand this step, you're done. Do you understand this step? Do you understand this step? Do you understand what I've done? I've taken the common factor out, but you have to remember that the x is in the denominator, so it's actually 1 by x. That is coming out. Make sense? Does this make sense? If somebody is struggling, let me know, because your 7 by 16 into 1 by x is what we write as 7 by 16x. Okay, that is why I have 1 by x out. Now 1 by x, when it goes to the other side, it becomes x. So your x is simply 7 by 16 minus 3 by 10. In the next step, when 1 by x goes to the other side, it goes as x. Right? Now you have the answer. You just need to simplify this fraction. That's all. You just need to simplify this. You have to look for common denominator. Okay, you see 16 and 10. You have to look for the least common denominator, least common multiple of the denominators. Of course, you can choose 160. There's no problem with that. You could choose 80 as well. 80 is the least common denominator. It is easier if you choose 160, because you can straightforward, you can directly multiply with 10 and 16 and you write 160 here. Okay, if you have trouble with this kind of basic arithmetic, do get back to me. Okay, I mean, that should not happen, but in case if you have any difficulties in understanding the basic ideas, do get back to me. So it's basically 70 minus 48 divided by 160. So that is going to be 22 divided by 160. And 22 divided by 160 is going to be 11 divided by 80. Okay. I'm sorry, we are run out of time. So listen carefully. I will share these two sheets with you. Please take some time and try to work out these questions. We have seen so many questions, right? We have seen so many questions, and you will be able to crack these questions if you spend some time. So remember two things. One, do not use calculator. Two, get a sense of time, like how much time you're taking on an average for each question. Okay, do not use calculator. Even if it's a calculator question, I would have mentioned that it's a CA question. But even if it's a calculator question, do not use calculator. Okay. Try to do it with pen and paper or doing mental math. All right. So we'll continue in the next class. I'll definitely do all these questions in the class, but the idea is you have to do it on your own. The only way to learn math is to do math. Okay. See you in the next class.